I think we've got some excellent people waiting backstage to
Indeed. Let's bring
share
them on.
something cool. Yeah.
Yeah.
Two super prepared people who have been waiting backstage for a long time, quite clearly watching the last talk, but I can tell that you're like ready to go.
Yeah, this is so exciting. I'm so happy to be here with you guys. Thanks for bringing me on.
Very good. And we're super excited to have you because I am personally, I have to admit, because I teach design to data science students. And connecting these two topics is something that you will be talking about. So the principles to enhance UX of your data analytics. So I'm really curious on sort of what the topic will be focusing on. And you are being brought here by IterateUX, one of those other communities which are not tied specifically to a location, although if I remember correctly, it started in Canada.
Yes.
Yes, thank you for confirming. But they are sort of by design and by birth a global community. So nothing else to that from our side, except thank you very much for being here again. IterateUX was around last year as well, I believe, then not with a talk, but with a workshop. This time around it is with a talk. And Alice and Taylor, we hand the stage over to you.
Awesome. Thank you. Let's see.
Beautiful.
Okay, cool. Yep, we have our talk and presentation up. Okay, Alice, you can go ahead and start us off.
Sure. Hey everyone. This is IterateUX. My name's Alice, who's the host for IterateUX, of course. So actually, are you sharing?
Yep.
Okay. Yep. So today we will like to talk about data experience and data analytics. Before we move on, we would like to show you. We would like to talk a little bit more about what IterateUX is, because as designers, we love to share with other designers, especially grow with others. So we do provide free weekly events, and we have coffee chat sessions, design feedback, portfolio review, design challenge, and whiteboard challenge. All those service will be mentored by the senior UX designer. So if you have any question or you would like to have someone to help, IterateUX will be a place for you to grow with all level experience and all level background, because we just want you to have fun and grow in your career. Okay. I would like to talk about what's going on today. Our lovely speaker, who's Taylor, he's going to talk about data experience and data analytic. He is one of our perfect, awesome UX mentors. So I really hope you enjoy our presentation today. I'll hand it off to you, Taylor. Enjoy, everyone.
Okay, thank you so much, Alice. It's so great to be here and to talk to everyone today. So I'm going to go through and talk a little bit about data experience and, like you mentioned, a little bit about how we can enhance our data analytics platform. I think the UX and data can be such an interesting kind of space where you can combine those two together. And we're going to be kind of walking through some how we can do that today. Before we do that, I just want to introduce a little bit about myself, who I am, and what kind of got me interested in data and combining that with product design. So 3, 2, 1, go. On the personal side for me, I love to travel. My girlfriend's from Peru, so I travel there about 2 times a year for about a month each time. I loved video games. When I was a kid, I used to go the opposite direction around the Mario Kart track and try to jump over like these different areas and explore. I think designing fun is such like an interesting and unique thing to do. And it's something that like I've always been kind of passionate about. I've played guitar for about 10 years. That's me on a dinner date with Machine. I was a referee for about 10 years, and I was so done with people. By the end of it, I was kind of acting like this guy. And then I have a little dog named Miko, who growls at people when they go down the stairs. I make fun stuff. So I originally got interested in data. I was a developer by trade, and I used to build these really cool kind of data visualization experiences that you could kind of go through and explore. So One of those was using an Oculus Quest 2 and being able to put it on your head and be able to fly around Indianapolis and see where people were tweeting when the Indianapolis 500 was going on. And I kind of slowly took some of those aspects of data design principles and started thinking about, oh, what ways could we apply some of that data experience components and align that with design as well. And from that, I became a product designer, and I make more serious stuff now. We, as a team at Splunk, design prototypes that can be turned into full business products. I make very, very complicated enterprise problems easier. So if you have terabytes or even petabytes of data, being able to ingest that and make sense out of it, that's my jam. For an introduction on what Splunk does in particular and where I kind of fit into that, we are what is considered the data to everything platform. So anything that has to do with your security, your IT, your DevOps ecosystems, we can ingest any kind of data that you can really think of. And our objective is we turn something that looks like this into something that looks more like this. And so what you're seeing here is various different kinds of dashboard experiences. I work more primarily on incident response and data experience in Splunk, and thinking really carefully about how we ingest and mold that data into something that makes sense for our users. I think of data kind of almost like if you were a blacksmith and you had the metal and you hammer that metal into something that's actually useful and usable by your organization to make your business decisions around. I fit right into that as far as helping mold those experiences so our customers can build dashboards more effectively, and we can build those dashboards more effectively internally. So I'll be covering today 3 major topics. So what is data experience? When I say data experience, what does that really encompass and why does it matter? Data experience principles, which are the individual principles we should be thinking about when we're working with data and we're trying to apply some of that with our product design knowledge. And then the final one, which is it's kind of underneath data experience principles, is adaptive complex systems, which is once we get to a point where we're dealing with enterprise solutions, what are some of the really interesting and kind of not easily defined challenges that we have to kind of solve for. So let me walk through this. Okay, so first off, what is data experience? The main thing, if you get anything from this presentation that I really want to get across, it's that data is very human in the way that we can use it. It's not just something like a scatter plot or a line chart. There's so much more to it. As an example, the American Academy of Pediatrics, when I worked with them, their main kind of thing that they thought around was how can we take data from developing countries where they have issues with neonatal asphyxiation during birth. And during neonatal asphyxiation in developing countries, the mortality rate is around like 23% versus in the developed world, it's more around 0.1%. And so they wanted to understand how can we take data of why this is happening in developing countries and kind of shed light onto those kinds of problems they would be experiencing. And from that data black box, and once you kind of fill into that data black box, how can we better train the nurses so that they can save these infants more effectively, as well as get the proper equipment to them so they don't have those issues in the future. It can be something like Rolls-Royce, where Rolls-Royce takes their data of their individual aircraft engines, and what they do is they use it for monitoring in flight, as well as feeding that to the captain's cabin, but also for things like taking their data and applying it to their maintenance, repair, and operations component. And so by taking that data, they can really hone in and build innovative ways of training individual individual customers, so, and their internal people. So I'll walk through this probably near the end of the presentation. I worked a little bit on this near like 3 years ago. And then at Splunk, they take the data, and McLaren, they take the data that is generated from their qualifying laps and their races to be able to understand their individual cars and how they're running around the tracks. So the PSI of their race cars, their tires, the temperatures, their sensors on if there's anything wrong, all to eke out like a 0.1 second difference that can make a determination on if they qualify one level ahead or one level behind a competitor. And what I'm trying to get across from the majority of this is data is something that is very personal to people, and it's what drives people's decision makings at all levels. Whether you're at high level and you're an enterprise business decision maker, or you're starting out for the first time and you're trying to convince your boss to maybe move in a direction personally, data is something, and the way you communicate data is incredibly important. As an example, it can be even to the point of it being, I would say, life or death decision making around the way people understand data. An example of that is something like the Columbia Space Shuttle disaster. And this is an example of how you read data visualization and kind of a case study. The failure of the Columbia Space Shuttle when it launched was due to failure of O-rings that were a part of the fuselage. So it basically segments the individual parts of the engine and the fuel that's associated with it. And what the problem that was known before the launch that eventually resulted in the explosion, they knew that there was an issue with the O-rings and the differential of the temperature being significantly lower than they initially, than any other launch they had done before. And so the engineers built a visualization that kind of tried to communicate that. And if you're looking at this visualization, it's very, very difficult to kind of understand what they're trying to communicate. The way you're supposed to read this visualization is at the top, you're supposed to read the temperature at the very top of that rocket. And then if you see those little bitty squiggly lines kind of like along the edges here, these are meant to indicate an O-ring failure that's been a part of this. But if I'm trying to understand the trend of the temperature and the relationship to the failures that have occurred, and I'm bringing that to my manager to say like, hey, this is like way outside the realm of anything we've done before, it's not really being communicated very effectively. And so, if you built this visualization, these are some of the other visualizations that were built a little bit different. What this visualization communicates is when they showed flights with no incidents out here on the right of, O-ring failures, there's very few of them. There's a couple like above, but over the majority of the distribution, it's not really, as significant. But when you start moving here to the left, you're starting to see a little bit more of them. And then when you visualize it out further to show like the huge difference in the variability here, you can immediately see, like, again, if you're thinking of this as a user, oh, this is way outside the norm of, what we've ever done before or experienced before. And so when they calculated this after the space shuttle disaster, they calculated at a 13% likelihood of failure of the O-rings instead of NASA's typical expectation of it having to be around 0.001%. And so the way you communicate data can be incredibly effective as a part of your system. And data is very human. With that, let's go over some data principles to kind of start thinking through, what are some things that we can do with our data that make it a little easier, and how can we leverage really our specialization as product designers into those use cases of data that exist. The general problem, I would say, like the biggest problem that I find with most organizations when they create something like a dashboard or a visualization is they come in very unopinionated. And it's the same kind of problem you can probably think of in UX design, where someone says, oh, we're trying to solve 50 issues, right? but they haven't really gone and talked to customers to really understand their needs. And they're kind of going off their gut feeling. And so it's the same kind of thing with dashboards where they'll be like, oh, we want a dashboard that improves efficiency or shows different kinds of trends or solves different system problems, but it doesn't end up doing any of those. An example of that, this one's from the London City Government website, is an example of this. This is an example of one where it's trying to do everything, and this is more of an exaggeration, I would guess, than anything. But you have something where you have weather stations, you have the tube line status, you have the BBC local news, Twitter trends, even I think like bike sharing. And they're not focused on resolving any one problem. And so dashboards and visualizations should be like, you should be asking questions such as, is this a dashboard that should be solving something operationally that people are like, there's a problem, I need to go and solve it? Is it investigative where I'm like, okay, I have time and I really want to dive into something and see if there's outliers in my system? Or is it business specific of I want to look across all of my organization to understand what's happening in the context of the broader things happening as far as business service intelligence or something along those lines. Other problems you can kind of see with this, because it's so unopinionated, you end up with things such as colors kind of conflicting with each other. As an example, red being kind of used as a signifier of, oh, this is a failure state, or, this is something you should really draw your attention to that you need to look at. Well, we have red for wind temperature, but we also have red for the tube line status of Central here, which says it's in good service. And if I look down here at the bottom, the electricity, it's in red as well. And it's like, okay, well, is the demand like high if it's red, or is it red if it's like, I don't know, like maybe it's, I'm trying to think of an example off the top of my head, but there's different reasons it could be red. Like maybe it's is it like by the time of the sun, is it summer or winter? Does it increase? Like there's nothing to compare it against. So because there's no comparison of your visualizations and the colors are conflicting, you're not really getting an understanding of the data, and your eyes kind of bouncing around everywhere without getting an understanding of what's happening. Yep, I see everything and I see nothing exactly. And that's what, us as product designers, our superpower is going in and really giving that specificity to it. In my case, an incident response, we create like the problem statement is, as a system reliability engineer, I want to identify severity of an outage, who needs to be involved, and what services are affected, right? So maybe out of two of those, they're more along the lines of, I need these as like severity and what services are affected are indicators. And then who to bring on would be more of an actionable thing, like a CTA that I might bring into the application or the dashboard to as like the most important things the user will do from the action, from what they see as a part of the dashboard. We have examples of this inside of Splunk in particular, like some of our example dashboards that show some of this. So this is an example of data center sensors. The main thing I want to kind of communicate here is, we have examples in product design where we, I think it's Nielsen Norman heuristics, where it's like, oh, relationship of system to the real world is like super important. Well, you can do the same kind of principles in the hierarchy as we do in dashboards. So being able to communicate, if I am a person who is really interested in understanding the efficiency of my data center and visualizing that, and I'm sitting right across from my data center, then I know that, in C5 over there, there's a high temperature spike and maybe I need to go and investigate it. It's attached to the real world and I can go over there and like investigate it. And it's related basically to the context of where I am in my own environment. that was more of an operational dashboard, but then you have examples of more business-focused dashboards. So this is an example of a business dashboard for IoT manufacturing of cars. So you have examples at the top of single values of things such as business operation metrics, your overall equipment effectiveness, and then again, the visualizations or your not iconography, it's the wrong word, the images here help give kind of the context of like, what does the assembly line look like underneath me? And if I go out onto the floor, do I need to go over here to resolve an outage or a problem with it? And I immediately get, like, in 5 seconds of looking at the dashboard, where the problems are in these visualizations. Number two, and we kind of talked a little bit about this, but also eliminating or prioritizing complexity around your dashboards. Again, going the top level for this one was just saying like, hey, people often overload their dashboard with way too much information and not specific enough, instead of using negative space to kind of build that hierarchy. As well as underneath here, they'll oftentimes put like this iconography of like, this is our corporation, and that corporation uses really complex graphics that conflicts with the dashboard content that you're trying to get. Most people who are using your dashboards are going to be more internal folks, or maybe clients, the people who not really the front end users, so they really don't care about your branding as much. There may be a couple use cases. Again, you interview your users, they say it's important, great. But for the majority, I would say, of people that I've talked to in data, it doesn't really matter as much to them, and they waste a lot of space by doing that. An example of like something eliminating, or like something being way too complex on what you're trying to solve. I grabbed this visualization. Again, these are exaggerations as examples of like what not to do. But this is an example where a teacher views the individual students, and from those individual students, they have all these kinds of details around like, oh, what's the spread of their grades over time? What was their last like numerical value versus like their current like grade that they got on the last test? Oh, it's like attendance. They have this weird bar that's like, I think there's no legend here. So it's like, I think the purple ones, the pink ones at the top are like, they've attended. And the gray ones at the bottom are like, I didn't attend. And then like, if they've been written up like behaviorally in the past. But if I asked you, like any of you who are watching this, and I said, well, if I looked at attendance, if the user says, or the teacher says, I really want to understand who has been either attending the most or least, or has the most absences, at a glance, I'm not going to get any of that information, right? The same really, like this is categorized by their number, but I'm not really getting a sense of how my overall class is doing, or really how the individual user is doing, like the intended graphic is supposed to do. And so part of this is like, when we're thinking about dashboards and data visualizations, is like building the context of like, what's the first thing the user needs to see? And is there ways when we eliminate that complexity, or we take that complexity and say, as a user, I want to see I want to see a aggregation of my students. And then by clicking on an individual student, then we surface the data that's maybe secondary or trinary information to our context. I took 30 minutes just as an example. This is like very rough of just me like jotting down the way I'd reorganize some of that context. But like taking 30-minute exercises of like, okay, what's the most important thing they want to see here, like as a teacher? And again, this is me going off my own biases. I want to clarify, I didn't talk to any teachers. I would have talked to users before I built this. But the flow is, you talk to users, you understand their needs, and then I visualize it and compartmentalize the features that matter most to them, based on their problems, like we do as product designers. And then by diving into each of those problems, specifying my knowledge and saying like, oh, based on what you told me here, the best visualization we should use for this problem is a single value chart or a table. And by clicking on the table, or like say like the individual like detentions or absences or referrals, whatever, then I get like a breakout of that content, because it isn't that important to me, at least as the starting point of my investigation. Let's see here. The number 3 data principle: analytics should facilitate action. Similar to what I was talking about, where your analytics platform and what you're trying to do, they shouldn't just be like, they can just be static, like, and tell you something. But one of the problems with dashboards that are just static is they don't often lead like a user to say, okay, what next? What do I got the information that I investigated. How do I utilize that and build on top of that in the future? It's kind of just expected, like, oh, I see it, maybe I take a screenshot and I send it off, or I have to go in my system and then like go to another system to actually act on that data. So good data visualization often like exists in the same space as the problem that you're actually trying to solve for, right? So if I'm looking at this and I see like, oh, user, whatever, like Mark Cuban, who's a part of apparently my high school introductory to astrology class. Mark Cuban is going to, I can click in on him. And then if I see some statistics around him that I'm interested in, maybe a number of absences, I can message him directly from there, or it gives me some context of actions I should be performing along with my data analytics. The other kind of thing you can do is you can highlight the most important parts of that hierarchy as a part of your dashboard as well. So again, the context is I would interview, my teacher or the teachers that I'm doing this with, and they would say, hey, I really, what matters most to me is seeing the number of absences that are important. If there's like a huge, like maybe a spike from someone, or there's a deviation from the norm, in which case what I would do is have something maybe like a context box at the bottom that really highlights a couple of those key details that I really want to point the user to, that's maybe 2 or 3 levels deep, that they can hyperlink down into if it really matters to them. Otherwise, it's fine if they stay at that top level and they're seeing that aggregation. A couple ways of keeping them in context without like opening an entirely new view. This is an example of data experience with motion and visualization. This wasn't done directly by me. This was done by a colleague of mine at Splunk. But the idea of this is, again, a lot of these visualizations that I see are very static. You can't do anything with them. And one of the things you can do is you can, like, as an example, maybe I'm interested in the altitude over time per plane type. By clicking in on this visualization that you see here, as you see, it just has the normal legend, but by clicking on it, it exposes more levels of data that may be important, such as like my average and min and max. So it doesn't just exist in its own isolated silo. It lets me dive into the context a little more and a little more. It's the same, like you can think of servers kind of like that, many different kind of architectures where it's like a object and I want to break that object apart as I go further down the line. Number 4, choosing the right visualization for the right problem. And this is a little more just looking at each of the individual visualization types and thinking about how we can apply it. The first one is, I'll just kind of walk through these, but single value charts. So single value scale to any kind of device. I love single values, and I love like single values with spark lines under them, because they really, like, as a designer, they have whatever priority I tell them to. They can be as big or small as I want on the dashboard. They're really good at hierarchy of being like, in 5 seconds for a user, what are like the key metrics that they told me that they value as most important, and how can I highlight that really at the top? Let's see here. If a couple other things like the filler gauge is good if the minimum, let's see here, I'm looking through my notes off the top of my head, sorry. Minimum, maximum, or static. I don't know what I wrote there. 1 second. That's bad on my old me. Oh, visualizing against a medium. That was one of the things I was saying here. So like, as an example, like the 0 and 100, if I'm wanting to visualize like the differential between like a standard point, maybe it's like the standard point for me is the CPU temperature should be 60 degrees. And if it deviates up or down from that, I want to see it from that deviation point as the center point to know that. And so you can use something like these filler gauges as kind of to indicate that. Composition using pie or tree maps. They're a bit again, this is my opinion as a product designer, I think they're a bit overused sometime, but they're great at showing relationships rather than exact values. So in 5 seconds, if I want to know, green versus yellow, red, right? Like good, warning, error, right? In 5 seconds, I can see like, look at that pie graph and I see immediately like, oh, the sliver's this small or it's like this big, right? At which point it's like, we don't have a problem, we have a problem. Same with heat maps is another good example of that. And I'll show an example of that here in the future. Stacked area and stacked column charts are good for viewing high level trends between like highly correlated data. So like gas prices or something like that, they work really well with like stacked area or stacked column charts. Complex system statuses, like we use Choropleth, it's a word mouthful, Choropleth map. And what that does is it ends up kind of ending up, I feel like a lot of the visualizations that use that, it becomes the center point of your context around your dashboard. It oftentimes ends up being highly interactive, and you can augment that a little bit by also applying, say, your data visualization over top of that. So like if I have hover states, I can apply a single value to show more details, or really kind of zoom into those pieces through maybe like a drawer that pops out as well. And then your old reliable, which I see most of the time, is line and area and column charts, which show your trend data over time. But often, like I said, lack interactivity. I don't think it's due to the nature of the visualization type. I think it's due to people just like throwing them up and not really giving context or actions users can perform out of them. Let's see. Next one. So once you've built a dashboard, like this is an example, I believe, of the Europe. This was a example one for Europe Network Hub. You can apply single values to that example I was talking about of images over top of it. To really like indicate and still have that system link to the real world that you're trying to showcase, as well as this is a bit complicated in my opinion, but it's still kind of showing like as an example, if I'm trying to understand a relationship or how it feeds out from the central server. Oh, in 5 seconds, I know there's a problem over here. I know there's a problem over here. And maybe by clicking on that particular line segment, it dives me into that problem so I can start actually getting some resolution or ideas and context around the problem I need to solve for. An example, I'm going to go through an example of me choosing the right visualization for the right problem. This has to do with mobile design. I'm currently the mobile designer on the observability platform. So this is the context around this problem is inside of our web app. We have something that looks like this for our heat maps. And again, going back to what I talked about, heat maps are great for getting like in 5 seconds, I want to know like a rough idea of the percentage that are failing versus succeeding, right? And they're very scalable. It's almost like actually the smaller version of this that you see right here, is more valuable than the larger version, because the larger, it takes up more space. I'm not getting kind of that context around everything that's going on really rapidly. But the problem was when we tried to like implement this and we say, okay, well, that's great, we can just apply this to mobile, it'll work fine. Well, the way it works in the web app is I can take my mouse over any one of these individual elements, and then it brings up like a little modal over top of it that explains, okay, these are the internal components of each of these. So if it's like a server or Kubernetes cluster or whatever, it gives all that detailed information in a list that pops out that I can scroll through. But in mobile, the mobile specific is that you want it to be around 44 points for 44 points to be, or 44 pixel to 44 pixel for web to be a tappable area. And a cursor can be a lot more specific than your thumb. So you have to keep it a certain size, but the problem is if you keep it that certain size, then, well, you can only show 8 individual squares. So if I have 120 squares and I'm trying to get a concept of like what's going on in my system, I'm not getting anything. Just being honest, there's nothing I'm getting from this. And you know, I could expand this to like just be a giant list that's like taking up 20 pages of this, but it's like, well, that's terrible, to be honest. So what do you do? And, you know, I'd question you as product designers, what would you do in this situation? Well, you look at the context of what the problem is trying to be solved here. And so you don't look at necessarily the visualization. The visualization is a part of a toolkit. It's the same as like we use hierarchy or color or typography. It's a guideline or expectation of the way it should perform, but we can break from that if it makes sense. So in this context, we looked at it and we said, well, this doesn't, you know, this isn't going to be valuable for our customers. So we said, what can we do different? So in this middle one, what we ended up doing was making almost like this vertical bar that you could use as part of the solution. And again, the process and the thought around this is I want to know errors versus warnings versus successes. Then I get that general idea really rapidly. Then what I can do is a couple other interesting insights was it doesn't matter so much as far as like being exact on the width. So like as an example, the width of this red is supposed to represent the number, right? But if there was 500 and there was one error, it would be so small of a sliver that I couldn't actually click on this, right, with my thumb or tap on it with my thumb. So it's better in some cases to be like, okay, well, we sacrifice accuracy as a part of a little bit of that data and say it will be slightly inaccurate, but we keep that tappable area so it's easy for the customer to be able to click into that and get like 2 levels in deeper, and then make a decision to say like, oh, this number isn't really as important, because if it's still a tiny sliver, it still doesn't matter as much as it being like, when it starts mattering is when it's 25% or 40% of the visualization. Other ways we kind of accommodated that was at the bottom having tappable areas as well that tell you the overall count of the visualization. Okay, so we ended up making something that ended up looking like this, and you could actually dive in like 2 levels deeper as an example from that stacked bar. So our heat maps now actually take that visualization and expand upon it. And so I can go into those individual signals, or they're called signals for us, but they're, again, like say I'm interested in the IP network outage here. Those individual signals are clickable. I click on it and then it opens up an entire list of all the details around that signal, rather than just having this giant table of information. Okay, so let's see, what time am I at? 10:41 for me. Okay. So I'll go into the next point, which would be, this is starting to get into the really, really complex stuff, but leveraging data with what's called adaptive systems. So first off, let's define what an adaptive system is. So to do that, let's talk about every designer's favorite thing to talk about is ants. I know everyone loves ants here. It's just, first thing I ever talk to a designer about, it's ants. But when you think about like the way ants work, a single ant has a small number of actions that it can actually perform, and there's a limited number of roles and responsibilities that that individual ant has. And so if you're trying to monitor what, like a small ant is doing, it's really pretty easy. But at when you start scaling up this and you start looking past like the individual and you start zooming out, there becomes this system that starts to take form, right? And so through all this noise, you're almost getting a picture of what's happening with your system. And so each action of the individual ant could end up being like slightly random, and you could guess what that slight randomization around the action could indicate. And it would be pretty easy to say like, oh, this is 75% likelihood the ant will do this versus 25% likelihood. But through all those individual ants that are all doing different things, it becomes almost impossible to try to get an idea of what's happening with the system. That's generating all these tunnels for storing eggs, supplies, and what I imagine is the ant equivalent of an HGTV dream home. We still have that same problem when we're thinking about system design at the enterprise level. Data systems act in a very similar way. And when you start to scale data experience into the realm of like financial markets, security orchestration, development operations, meteorology, there's like an inherent amount of chaos that's just like with everything. And so being able to make sense of like this loosely stringed together data with significant knock-on effects that if one small thing changes, it changes everything down the line. How do you start building systems and really designing data around that kind of context? Like at the enterprise level DevOps platform, giving that as an example, we have an insane number of toolkits, all with different kinds of use cases and pain points all around your different app development lifecycle. And each of those individual users are carving out their own fragment of truth about the way that system functions. So, if you're a developer and your system, like your checkout service goes down, and you're looking at this, like what tool do you begin in to actually start resolving the problem? And so as designers, product designers, I think what we have to think about is that there's this graphic that I love. I don't know who it's made by, but whoever it did, I could kiss you. It's amazing. Is the data experience is thinking about how we successfully democratize individual levels of understanding around the way data is flowing through a system. So if I'm interested at the first level of like data, and it's all these little bitty points that I may not even have in my system, how do I understand that and understand what's important to me? If I have a context around those points, how do I start building that into actual information? If I have like really dissonant like locations of points of things that are happening with the system, how do I highlight those two that are like across the entire system and kind of bring it to the forefront for me? And then how do I do something like wisdom, where it's like, now I really want to build a presentation around that and really dive into like a story around the way this data is working. And it's not just like we want data to be wisdom. We want to democratize each of these individual boxes so they make sense for our users. And the last one I have is like conspiracy theory. I'll dive into that one a little bit, like at the end of the presentation. A couple things, like a couple other things we can do is when we're thinking about those little boxes, what other toolkits can we actually use to surface contents for the users? And so what we can do is we can use predictive analytics. So as an example, in incident response, there's a problem that happens, my service goes down, checkout goes down. Well, there's preparation around that that's already been built up. There's a detection of that problem. then there's a containment and looking into the actions of it, and then there's a post-incident review of saying, what could we do better? And so when you look at each point of the life cycle, you can use toolkits, and it's an overloaded term, but AI and ML, to provide and say like, okay, well, this person was in this product at this time looking for an issue, and they found a resolution to that problem. And if this incident occurs and we see correlated data to that, can we highlight and kind of surface that information deep in the layer of whatever that data is, that noise, to the user, and from their actions that are being performed, really hone in on, are they actually getting the right information to solve it? And if they say no, and like they're explicit about the data that's being populated up front and say, this isn't useful for me, they can go on about their business. But if it is useful, then we can feed it back into this incident response lifecycle loop that continues to build and escalate into a broader system that will always say like, hey, I saw that last time this happened, you brought in the front end team, so we recommend you bring in the front end team right now. Or, hey, you always create a Slack channel and Jira ticket for this problem. Let's create that automatically for you and organize that. And is there a better way that you would prefer these actions happening for the user? That's what a lot of what we do, like in Splunk especially, is I'm using DevOps as an example, which is just like democratizing the data and being laser focused on starting with the life cycle at the core of our experience. We use recommendations to push the needle to a no dead ends experience. So if I'm in logs, it's always going to push me and say, hey, I see your related content over here in application performance or your infrastructure. It's all highly correlated. So it's less of a I am jumping between my toolkits, and more we're always providing like the next thing that we think you might like. I did want to point out though, like that's the positives and the things that we think about, like again, AI and ML, but there's a big asterisk to this that we want to think about too, right? And that's the general problem, like especially with prediction in the future. ML and AI, I feel like, are amazing for short-term solutions. Like what I mean by short-term is like in the near like day or week, I can get a really good understanding of the system, and like it provides good recommendations for me. But if I scale out, like say like the ant example, I'm not going to get a really good idea because the system will fluctuate so much. It's hard to actually tell what's happening. So I love like fine tech markets and the maturity of some of their adaptive systems, because the financial markets are so cool by their natural absurdity around like how they quantify everything. It really does feel like the market algorithms, like in the short term, they like could take the price and the latest Elon Musk tweet, the gravitational pull of the moon, Ariana Grande's latest single, and somehow figure that into the delta of the Apple stock by 5 cents a share for whether they should buy or sell it. But the main point of that is just like the individual consumer can't necessarily be a really, really good algorithm like in the short term. What we need to think about is that the longer term things that a person or a user is really good at understanding, they could really kind of dive in and digest that and kind of build context around what they think that long vision is. But adaptive systems and like the programming or the algorithms that help provide recommendations really do best when they're like in that short term analysis versus like that complexity scale of the big O, which basically just says like over time, you're just going to end up with something like this that's exponentially growing, and you're not going to be able to get a good view or an accurate view of what's happening with, say, a market or a DevOps platform. So for our users, what that really means is that prediction with data, and it becomes a partnership. It becomes a partnership between our user and our data. We often use terms like AI and ML as a black box, but they can't really exist without the foresight and guidance of the user to guide that ship. So the inputs and actions of the individual, I always feel, and why I am in user experience, even though I love data so much, are the most critical to this, are more critical, in my opinion, than any algorithm can be. Because an algorithm is by nature defined in a lot of cases by the biases of the individual user and the way they're going through that data. On that note, again, like this is another reason why we want to be very careful about this and like be very explicit when we're thinking about data, is that you are like the individual user is the captain of the algorithm in a lot of cases. So if they make bad decisions with the toolkits, it moves from being like useless to being dangerous. So people can inherently bias the algorithms for looking at trends that may not be there. So when you saw that little unicorn previously, they can be in the system for your algorithm can be inherent to bias to those biases and inherit it as well as, oh, you were looking over here, we should look over there as well. You can see this especially like in social media apps, in a lot of the controversy around social media apps on why they get so much, I feel like, public press and negativity around public press, because it's so incredibly difficult, and people often act like algorithms are the answer to everything or ML is the answer to everything without really understanding the implications of it or they do understand it, they just don't have a solution for how to wrangle it in. Leveraging additional value from data. This is the last point. I think I have 5 minutes left. I'll really quickly go through this, but this is an example of like, we talked about data analytics a lot here, but you can think outside the box with data a lot too. And one of the examples that I had was I worked with Rolls-Royce previously. So I think at the start of this presentation, I mentioned this, but they have their own maintenance and repairs of their aircraft engines. And so their downtime for their aircraft engines can cost millions of dollars when they're down, but they have IoT sensors that are a part of their engine. For those people who are the users, in this case, of I want to repair this engine, you're kind of dealing with something like this. This is a really terrible graphic, but the repair process of an aircraft engine has doubled in terms of like what you need to know since 1998. So at 1998, it was around 2,500 active manuals, and currently it's around 5,500 active manuals, and those pages have doubled. So it's around 33,467 pages per manual that someone who's repairing an aircraft engine needs to know, or at least be able to navigate through to actually repair an aircraft engine. And the last thing someone wants to do who's a repair mechanic in this case is have a giant stack of paper this thick thrown on their lap and say, okay, good luck. You got to figure out what's happening here. I can help guide you a bit, but you're going to have to read through all this. And if you make a mistake, you're going to be on Insider Edition the next day, and the Rolls-Royce will have an aircraft engine that will look like this from a passenger who took a video, which doesn't look good for Rolls-Royce, and it doesn't look good for their maintenance and repairing. And so you can apply, the one thing we kind of thought around was like, again, like data is out in the ether everywhere, right? You can apply data that was meant for one purpose for another purpose. The way it works for Rolls-Royce is they have all these sensors that monitor their pressure, their variable, like the air intake, all the individual mechanics and tools that are running inside of it. And it's meant to like know if a problem has occurred. Well, you could use something like we recommended this, and this was my college thing I did, but like ideating around it and saying, oh, you could leverage that data and be really smart about it and say, hey, I really want to show the tools, like as an example, that when you're repairing it, if I am repairing a part of that engine, having that manual be just beside me and kind of walk me through that process of what they need to do, and then use those IoT devices that are really a part of the engine to let the user know, am I providing enough torque to actually fix the engine here? What's the next step that I need to be doing? And thinking about applying a technology to that, like AR or VR, to resolve that. So this was like the final visualization I had. It's weird. There we go. Jumping around there for a second. Was like, oh, you could put on a AR headset. We feed the IoT information in around these individual engines. You could start out by training these individual repair technicians using the data that we leverage and 3D models that we leverage around those aircraft engines that already exist, and actually show them how they could repair the engine before they actually do the real thing, or they can do the real thing and get kind of this ghosting experience on the individual objects. I used a car engine here as an example using some video recording equipment. But like in this example, it shows that you're supposed to be torquing this individual bolt or nut, and then you perform the same action, and then it lets you know if you've tightened it enough. And we could attach that then to other kind of values, such as, say, my trainer, or being able to monitor to make sure they're doing the repair process correctly. That's it for me. I know we're all 2 minutes left, but I'll be in the Q&A session as well to kind of answer any questions. But thanks for everyone for attending. And if you have any questions, always glad to talk through this with you.
Awesome. Thank you very much. I'm also bringing Shaza on board. Hey, Shaza. Good morning.
Good morning, Peter. What time is it over there for you?
It is morning because it's 5 o'clock.
So, yeah, it's 11 p.m. for me. Sleep.
That's my sleeping for today. This was truly awesome, Taylor. I was thinking like, yeah, we're getting up to the minute. Like, when you have an hour, you don't need to do 60 minutes straight. It's to leave room, but this is great. It's been so good that I didn't want to jump in with slowing you down, because obviously we're managing the time well, and the content was really, really great. It was super good. So I know who I will be contacting for bringing some examples to my next classes in next semester. So hopefully you will be available. I don't know if there's anything you'd like to add, Alice, before we wrap up and direct you over to the Q&A, because we hope that you'll be able to join for Q&A session, because there's a lot of questions in the chat. That looks like a yes from.
Oh,
Awesome.
I didn't unmute myself. Sorry.
No worries.
Yep. So thank you so much for letting me wrap up this. I love this presentation. I was sharing in the Discord. I was like, Taylor just rocked this presentation so much. So thank you so much for this awesome presentation. We learned so much, especially you just mentioned about we need it's the best way will be using 5 seconds to identify the problem. That's really hard to do so. So the way you introduce and the way you show, it's really brilliant. Thank you so much for sharing that. So we will be in the Q&A session, and just wanted to let you know, if you actually have more questions in the future, feel free to definitely join our Discord community. We will be there to help you. And if you just want to hang around with designers, join us. We are IterateUX.
Awesome, thank you very much. So what I'll do is I'll hand it over to Shaza for introduction, welcoming those who are coming in new to 24 Hours of UX.